You know how your phone can read a check or how the post office seems to magically sort mountains of mail? Well, it feels like magic, but today we're going to pull back the curtain. We're going to see exactly how you can teach a computer to read something as personal, as messy as our own handwriting. All right, let's get into it.
Okay, so check this out. It's a handwritten number 9, right? Kind of loopy. A computer, the very AI model we're about to break down, looked at this exact image and knew it was a 9 instantly. No human help, nothing. Just pure computation.
And that's the big question, isn't it? How is that even possible? How does a machine go from just seeing a bunch of, dots on a screen to actually understanding a concept, a number?
Well, here's the secret. It's not magic, not at all. It's actually a process, a really logical one. You can think of it like this. First, we teach it. Then it learns. And finally, it takes a test. And we are going to walk through every single step of that process together.
So just like any student, our AI needs something to study from, right? It needs a textbook. And for an AI, that textbook is digital. So let's start there. Section 1, the digital textbook.
This textbook has a name. It's called the MNIST Dataset. And honestly, it's more like a giant digital library. I'm talking 70,000 different examples of handwritten digits, from 0 all the way to 9 scribbled by thousands of different people. This is the bedrock, the foundation for everything it's about to learn.
But you can't just hand the textbook over. First, you got to prep it for class. We take all that data and split it up. 60,000 of those images are for studying. That's what we call the training data. And we keep 10,000 on the side for the final exam, the testing data. Then there's a little bit of formatting. We reshape the images so the AI can see them right, and we normalize the pixel values. It's basically like translating the entire book into a language the AI can perfectly understand.
Okay, the textbook is prepped and ready to go. Now we need the student, and this is where it gets really cool. Let's jump into section 2. We're actually going to design a digital brain.
So how does this digital brain actually, see? It's not like human eyes. It's a really clever multi-step process. First up, you have these specialized layers that just scan the image for the absolute basics. We're talking simple edges, curves, and shapes. Then, the next set of layers comes in and simplifies everything. It's like taking a complex picture and boiling it down to just the most important parts. After that, all that visual info gets flattened out from a 2D picture into just a simple single list of numbers. And that's the final step. The last layer looks at that list and makes its decision, its best guess, based on probability. It's basically saying, okay, based on everything I see, I'm 99% sure that's a 9.
And here it is, the official blueprint for that brain we just talked about. I know it looks a little technical, kind of like an engineer's diagram, but if you look closely, you can see all those steps we just mentioned. Those Conv2D layers, those are our scanners. Max pooling, that's what simplifies the view. Flatten, well, that one's pretty obvious. And then the dense layers at the end, that's the part that makes the final decision.
Now get this. All told, this whole structure has over 225,000 trainable parameters. Just think of them as tiny little knobs and dials. The entire goal of the learning process, the whole point of studying, is for the AI to figure out, all by itself, how to tune every single one of those 225,000 knobs just right to get the correct answer every time.
Which brings us to my favorite part. It's like the training montage in a movie. Section 3, the learning process. This is where our brand new digital brain goes from knowing absolutely nothing to becoming a total expert.
Now, this training happens in rounds, and we call these rounds epochs. An epoch is super simple. It's just one complete pass through the entire digital textbook, all 60,000 of those study images. For this project, our model is going to go through that whole textbook 5 separate times, just to make sure it really learns the material.
And this is so cool, you can actually watch it getting smarter. This is basically the model's report card while it's studying. See the graph on the left? That blue line is its accuracy. And with every pass, every epoch, it just shoots up. And then on the right, that blue line is the number of mistakes it's making, what we call loss. And look at it, it just plummets. This is literally a picture of an AI learning in real time.
And if you look at the actual numbers, the improvement is just dramatic. After only one pass through the data, just one epoch, it was already about 90% accurate. Not bad. But after studying the material 5 times, its accuracy shot up to over 99.5%. I mean, talk about an A-plus student, right?
All right, so our AI has totally aced its homework and all the practice quizzes. But here's the real test. Can it use what it learned on problems it has never, ever seen before? It's time for the big one. Section 4, the final exam. And the final grade is in.
Drum roll, please. On those 10,000 images it was held back, the ones it never saw during training, the model scored a 98.89% accuracy.
Wow. So what does that number actually mean in the real world? It means that our model got it right for nearly 99 out of every 100 new numbers it saw. This is huge. It proves it didn't just memorize the answers from the textbook, it actually learned how to read handwriting.
And that brings us right back to the beginning. Remember this number, 9? What looked like a magic trick at first? Well, now we know exactly how the trick works. It's not magic. It's the result of having great data, a really smart design, and a successful final exam.
And the original analysis of this project says it best. It concludes that because the test accuracy is so high, the model is robust and, quote, ready for potential deployment. In other words, this isn't just some fun science fair project. This thing is ready for the real world.
But the work doesn't stop here, of course. The journey's never really over. The next steps are pretty clear. Get this model into some real apps, but also take a very close look at that tiny 1% it got wrong. Why did it make those mistakes? Because every mistake is a new lesson that can make the model even smarter next time.
And it really leaves you with a final thought, doesn't it? If we can teach a computer to read something as personal, as varied, as human as our own handwriting, and do it this well, it just makes you wonder, what are we going to teach it to see next?